I got this feeling inside my brains. It goes electric wavy when I make them A's. All through 4th grade, all through my school, we're flying up no ceiling when we're in our zone. I've got that sunshine in my pocket, looking forward to a good day. I feel I can do everything when I try. I can't stop myself from learning, moving up academically. Room unlock the way we rock it, so don't stop.
Hello everyone, and welcome back to measuring and drawing angles. Okay, so this is part 3, and this is going to be 2 TEKS in 1. Okay, so we're going to be learning about TEKS 4.6c, which is to determine the approximate measure of angles in degrees to the nearest whole number using a protractor. Okay, so basically we're going to be learning how to use a protractor. And then TEKS 4.7d, which is draw an angle with a given measure. Okay, excuse me. So we're going to be learning about what to do with a protractor and how to draw a given measurement. Okay, so let's get started. So work with me. Perfect, there we go. Our learning goal for today is students will know how to identify angles on a protractor based on the degrees. Students will understand how to use and set up a protractor correctly. And then students will be able to share in a group discussion how to determine the approximate measure of angles in degrees to the nearest whole number using a protractor, okay? Okay, I see. Okay, here is our real world connection. Okay, architects, so the people that design the plans and the buildings, use geometry when they make their blueprints for buildings. They have to understand how to draw angles so that their walls, roofs, and everything else are the correct angles measures. Okay, let's go ahead and watch this video and learn more about what architects do.
Hi, I'm Antonio Alonso. I'm the Regional Chief Architect for the GSA National Capital Region. My role is to review designs and approve design work that we hire our architects to work on our buildings. Again, we do large new construction and renovation projects, and my role here as an architect with the government is to manage the design and lead a team of other architects, engineers also, historic preservationists, interior designers, all working on these projects and reviewing them. Buildings have a great impact on our environment, and 1/3 of all greenhouse gases come from buildings. One of our favorite things that we've been doing is using green roof technology on many of our projects. When it rains, what happens here is this area of green absorbs water and doesn't allow it to run into the gutters and down into the street where it gets mixed up with the sewer system. It also keeps the roof cooler than a traditional roof, and so it serves as a form of insulation to the building. So what was used here at One Constitution were 2 types of lighting that were different. And one is called a compact fluorescent lamp, and it is a fluorescent lamp that is very energy efficient and lasts a really long time. The other is something called an LED light, a light emitting diode. These types of lights produce very little heat. They're cool to the touch. They last a very long time, and they're very durable. And they're also environmentally conscious because they're made without any type of toxic materials such as mercury. The architecture is an art and a science, so mathematics is very important. Geometry, for example, is fundamental to understanding, and it's a skill that all architects need to have. So study your geometry.
For more information on cool government careers, visit kids.gov.
Awesome. So these architects use a lot of geometry in math. Isn't that exciting? That's so cool. Okay, let's move on. So here's some important vocabulary that we're going to be using. Okay, first one is angles. An angle is two rays with a common endpoint. Remember, when they meet together, that is called the vertex. Okay, don't forget the different types of angles, which are obtuse, okay, measures greater than 90 degrees but less than 180. A right angle, which is exactly 90 degrees, okay, and then an acute angle, which measures less than 90 degrees. And then we have the protractor and degrees, and it measures it in degrees. Okay, so a protractor is a tool mathematics used to measure angles. The tick marks represent degrees, which is the unit of measure for an angle. Okay, so protractor is a tool to measure angles, and it measures in degrees. Okay, awesome. An angle is measured in degrees. Okay, count from 0 to the angle measure shown on the protractor. So for example, if it's a right angle, then it would measure 0 all the way to 90 degrees. Okay, let's go ahead and look at our mini lesson. So how do I use a protractor? Take a look at this protractor. Okay, the hole in the center of the bottom is where the vertex of your angle goes. So right here. Okay, so right here is where the hole goes, where the vertex of your angle goes. The black line close to the bottom represents the 0 degrees. So right here, 0 degrees. Here and right here, 0 degrees. The protractor is like a curved number line. Each tick mark represents 1 degree, with the 5 slightly longer to help you count. Every 10 degrees is labeled for you. You can start counting from either side depending on which direction your 0 ray points, so that there are 2 sets of numbers from 0 to 180. So if your angle opens up on this side, then you're going to use the top numbers. But if your angle is open on this side, then you use the bottom numbers. The bottom of the protractor is a straight edge to help you draw line segments and rays when you draw your own angles of any given measure. So you can use the bottom side to help you draw straight angles. Okay. Step 1 is to line up the vertex, the point where the 2 rays intersect, with the hole or dot in the bottom of the center of the protractor. Okay. So this is an acute angle. We're going to put our vertex right here in the bottom of the hole. Line up one of the rays with the 0 line of the protractor. Okay. So the bottom ray right here, I'm going to use it. I'm going to put along this 0 line, and decide if your angle is acute, which is smaller than a square corner or less than 90 degrees, or obtuse, which is bigger than a square corner or bigger than a 90 degree angle. Then you're going to look at the tick marks that the angle goes through. Be sure that you're counting up from the 0 where your bottom ray is. The angle. Okay, so let's go ahead and look at this. So we're going to count from 0. Okay, 0, 10, 20, 30, 40, 50, 60. Okay, so this angle measures is 60. Step 5 is to double check your work. This angle is acute, so we want to make sure that we measure less than 90 degrees. And 60 is less than 90, so we did it correctly. How do I draw an angle? Step 1, an angle is formed by 2 line segments or rays. To start, you need to draw a point with a line segment or a ray extended horizontally from that. Okay, so you're gonna draw a line like this. Okay, and then just make sure you draw either a line segment with 2 points or a ray which is 1 point and then an arrow. Step 2, the point should line up the 0 hole of the protractor in the first ray along the 0 degrees line, either pointing right or left, that doesn't matter. Okay, so make sure you draw it, you put your protractor where the vertex in the hole is at, and then make sure this ray is along this 0 line because it starts at 0. Step 3, Mark a small dot where the given measure would be using the protractor. Use it as though you were measuring an angle, okay? So here, draw an angle that measures 70. So that would be right here. So go from 0, 10, 20, 30, 40, 50, 60, 70. Mark it right here, okay? Not here because the 0 ray points to the right. This would be 110, okay? And we want a 70-degree angle, which is right here. So you count from 0. And in step 4, look at the tick marks that the angle goes through. Be sure that you're counting up from the 0 where the bottom ray is at. Okay? Nope. Oh wait, I already done this one. Okay, here we go. Step 4, now use the straight side of the protractor to connect the first point you drew, which is the vertex, to the mark you just made, which is at the 70-degree mark. Okay, to form your second ray or line segment. Step 5, to measure the angle you just drew to make sure it is the correct measure. And that's it. Great job. Smiley face. Okay, let's go ahead and look at our understanding. Where would you place the vertex of the angle you are measuring? Good, right there. Okay, hopefully you pointed to that, that's where you put your vertex, which is in the bottom hole, okay? Where should you line up your 0 ray? So the bottom ray, the bottom line segment. Where do you put that? Good, right here, the 0 edge. What would a right angle measure? So where would trace your finger along the protractor? Where would the right angle measure? Good, exactly 90 degrees. How would you know which set of numbers to use? So let's look at this one. So it's like this. How would you know top or bottom and why? We can think about this two ways. The top ray says it's either 55 or 125 degrees. It makes more sense to choose 125 because the angle is obtuse, meaning it must measure greater than 90 degrees. Or we can also start counting from 0 where the bottom ray is on the left side, and we can count up to 125 tick marks, which is 125 degrees. Okay? Remember, if the angle is open on this side, then use the top numbers, okay? What is the measure of this angle? So it's like this. So go ahead and count. I'll give you a few seconds to go ahead and count and tell me this angle is blank degrees. Good, 25, okay? So 5, 10, 15, 20, 25. Excellent. What is the measure of this angle? Oops, sorry. So this one right here, this big one right here. All the way over here. I'm gonna give you a few seconds. Good, the angle measurement is 165 degrees. Excellent. Okay, through which point should I draw a ray to create an angle measuring 35 degrees? Okay, so here's my bottom ray. Okay, so it's either gonna go from here to W, or here to X, or here to Y, or here to Z. Which one is going to create a 35-degree angle? Remember, 35 degrees, that's less than 80 degrees, so that means it's an acute angle. It's not going to be a big angle, it's going to be a small angle. W, X, Y, or Z. Good, you should have chosen point W. Okay, we could have counted 5, 10, 15, 20, 25, 30, 35. And this one was the only one that was pointing at 35 degrees. Okay. How can we find the measure of this angle? So first I would go ahead and use my top numbers for looking at these rays, okay? So this one is measuring 20 degrees, and this one is measuring, using my top numbers, is measuring 140 degrees. What I would do is look at both of them, and I would subtract to get whatever this angle is right here. So 140 minus 20 is 120 degrees. So this angle right here is 120 degrees. How did I do that again? Well, all I did was just figure out what angle this is. I mean, what this ray is right here, what this ray is right here, and I subtracted to get my leftover whatever this is, which is my angle. That's what I would do. Okay, there are two ways we can do this. First, we can count the tick marks between the two rays, tens mark it to skip count by, and we get 12 groups of 10 or 120. Okay, so one way was to just count 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100, 105, 110, 115, 120. Okay. The second way was to look at the measurement of each ray and subtract. Be sure that you're using both the measures on the top or the bottom of the measures. Top numbers would be 140 minus 20, which equals 120. Sorry, 140 minus 20, which equals 120. Or the bottom numbers, which is 160 minus 40, which equals 120 still. Okay, so this is the way I did it, was to just 20 degrees on this one, top numbers, because I'm using my top numbers, and 140 on this one because I'm using my top numbers right here. And I subtract, and I get whatever this angle is right here. How can we find the measure of the angle? Okay, either count the tick marks right here, or you can figure out what this one is, figure out what this one is, subtract. I'll give you a few minutes to do that. Okay, let's see. So how can we find the measure of this angle? So you could have subtracted, if we found out that the angle for this one using top numbers, this would have been 65, and this one would have been 110. And 110 minus 65 is 45. Or you could have counted 5, 10, 15, 20, 25, 30, 35, 40, 45. So this angle is an acute angle which measures 145. What is the measure of this angle? Okay, so it's already starting at 0. So you can either look or count, whichever you prefer. I'll give you a minute to do that. Awesome, you should have gotten 72 degrees. 72 degrees. Let's go ahead and look at one more. And looking at this one right here, what is the angle measurement of this angle? You should have gotten 170 degrees. Correct. Good job. Alright. The corner of this trapezoid was placed on a protractor. What type of angle is this? What is the measure of the angle? So first off, we're looking at just this. Okay. Well, it's less than 90 degrees because 90 degrees is right here. So this is an acute angle. And it measures exactly 80 degrees because it goes from 0, 10, 20, excuse me, 50, 60, 70, 80. Classify this triangle based on the angle type. I'll go ahead and give you a minute. So what is this triangle called based on the angle? Good, you should have gotten a right triangle because this is a right angle inside this triangle. The corner of this parallelogram was placed on the protractor. What type of angle is being measured and what is the angle measure? Alright, let's see what you got. You should have gotten an obtuse angle, and this angle measures 110 degrees. Good job. Based on these angle measures, which angle is an obtuse? A, B, C, or D? Let's see what you should have gotten. Good. B is what you should have gotten. B is the obtuse angle. Okay. Through which point should I draw a ray to create an angle measuring 100 degrees? Good, you should have gotten point Y. Y is the one that measures exactly 100 degrees. Alright, exit ticket. Here is your exit for today. Circle the type of angle that has been placed on the protractor, either acute, obtuse, or right. And then find the measure of the angle, okay? And go ahead and write this in your journal. And that is it for today. I hope you have an amazing day and you learned so much today about angles. Have a great day. Bye. See you next time.